Welcome to Golang Code Generation Basics. What will you learn to do? Well, you will learn the basics on how to build a code generator in Go. A simple example is shown to get you started. All the code discussed here is available on GitHub and linked in the description. So why code generation? There are many cases where a lot of the code is the same, but only differs in some slight variations. An example of that are CRUD database operations. Here, the basic CRUD code is like 90% the same, with the only changes being table and column names. And only if you have some more complex queries for the database does the code differ more significantly. So, why not just generate a code that is 90% the same? Well, so how do we actually build the code generator? First of all, let's start with creating a template. This is where you will store the code that you will actually output. And to generate the code, you can use the text template library in Go. Then this is simple template definition. You can see here, you would put this, for example, in your generator template, simple example temple file in your project. And now, what does this mean? So define simple example. This starts a new template with the name simple example. And the end here marks, well, the end of the template. The name here, dot name, refers to a field at a struct that is given to the template as the data. So a struct that fits that is like this simple example here, type example struct and name string. So that's the only thing here. So the idea is that it prints hello and then whatever is in the field dot name. How do you execute this template? So this is the most simple way to execute this is to first this line with template pass glob loads all templates files inside the generator template directory that end with .temple. Next, the second line. This creates a new buffer with bytes.newBuffer into which the template will be written. Then we instantiate our data object, which in this case is the aforementioned example with world as the name. And finally, template execute template is called, and it's given the buffer to write to, the name of the template to generate, which is simple example, and the data to put into the template, which is this example here. And then you will get the output hello world when you run this. Of course, when generating code, it's not enough to just write it to your console. You also want to write it to a file, of course. For this, you can use this simple function. It gets the buffer, which we've written to, and then it creates a file, the output file we define with path string. And then it's opened and we have to close it at the end. So that's why defer output file close. And then it's a simple output file dot write and those bytes. And that's it. So putting it all together, I will show some code. This is the simple example here. As you can see, there's our example struct. There is template, the string function, which is what I showed you how to the template into a buffer. We print out that buffer to the command line. Then we turn the buffer into a bytes array, which we then write to the file. This is the file write function I've shown also. Yeah, so now can just run this, right? And just to show, this is a simple example. Oh, this is spoilers. I delete this. It's from a previous run. So let's run this. Prints out hello world. And there's a simple example with hello world. Moving on, there's more directives like for the template you can use to create more complex templates. So let's start with a new template example, which is called range example. And it starts the same as the other example with hello and then the name. But now we're also adding this range. So it's similar to define. I mean, it starts, so this is the directive range, and then it references an array field in the struct, and end marks again the end of the range. So we iterate over this hobbies array, And this dot here references the value, one value inside this hobbies array, which in this case, this is our example struct, is just a string. So dot will just output the value, which is a string. Now executing this template, so template to string, then we create our range example struct with the name and the hobbies here, and well, it outputs, as you expect, every item in this array. Then another important directive is an if, so same base example, and instead of range, we have the if, and find show more, in this case, is a Boolean, and this will only be printed if, well, if show more is true. That's all there is to it. Here's the example struct, simple Boolean, as you can see. Now, executing it, execute it with show false, then there's only hello YouTube. But if you execute it with show true, then it's hello YouTube, you're awesome. Okay. Now, let's go to a more practical example. We're here to generate code and not some random text that doesn't mean anything. So, what do we want to generate? The idea is create an enum here for the to-do struct. In this case, the state of the to-do. Strictly speaking, there are no enums in Go, but it is possible to somewhat emulate them with a string type. So in this case, type to-do state string. And then we also want to automatically generate a stringer, so the string function for this to do, so you can print it in a nice way, which you don't get in a standard way. This is what we want to create. So let's start with, call it an entity struct. This is not the, this is like a template for the code generation. And so we're gonna, from this, we're going to create our to-do struct, and this acts as the template. So it defines the fields, so name, string, check, boolean, and then we have our state. And now this here is a tag that can be added to struct fields. So this can be an arbitrary name, an arbitrary value. You can define whatever you want in here. And in this case, we are defining the enum values we want to add to to-do entity at the field state. So next, going to pass this struct using the reflect package, more on that in a moment. And this is the output of our parsing. So we have a parse struct here. This is the name of the struct to generate. In this case, it would be to do. The package into which to put that struct, which will, in this case, is also to do. Then there is an array of fields to put into the struct and an array of enums that are also need to be generated. So how does parse struct field, what does it look like? Well, it's just the name, the field, and the type of the field. So for example, for this here, it would be name, and value would be string, or checked would be the name, and bool would be the value. Then we have our parse struct enum struct. This is the name of the enum to generate and the values to put into this. And the values are also again name and value, which corresponds to this here, created and created. This would be the name of the value. No, this is the name of the enum, right? And this is the value to output. So what does the code for parsing the struct look like? Let's have a look at the code. So these are the structs that will result here. We already seen them. Now the code. So we're using the reflect package, or the reflect type of, get the meta information about the struct. Oh yeah, forget the inputs. So we put in the struct name we want to generate. In this case would be to do, and the package name we want to put it in, which would also be to do in this case. So this takes care of those two fields. And then it's time to pass the fields inside the struct, which we can do with this resulting. So we have type of reflect, and this object contains the number of fields over which you can iterate. And this is how you get an individual field. Now let's get the type name of this field, which could be string, boolean, int, or another struct. We check, is this an enum field? So should this field be turned into an enum? And how do we see that? So, well, if it has field tag, so this is the tag I talked about, If it has an enum tag, then it's an enum. Now, we actually changed the type name for the generation of that field we concatenate it to struct name and field name. So this would result in to do is a struct name and the field name is state. So that will result into to do state. Okay. And now we add to the enums array a new enum, a new passed struct enum. This is the type name again. And now we pass those enum values. There's another function which we give. There's another function with which we get the enum values. So from the tag, the string, and if we split that string by a comma and get the string array out of it. This goes into another function to get the struct name and the field, the name of the field. And now we're creating those values for those enum. So we're iterating over those values. And then we format the name again. So this would result in struct name, so to do, the field name state, and then we have the enum value. So it's already auto-completing, it could be created. The next field like would be reviewed. So yeah, this is the name. And the value is just the value which would be created or reviewed. Yeah, that's it. So now we have our enum. And now for all fields, we add a passed struct field with the name of the field and the type name. And that's already it. Easy. So let's talk about the template. So we have our structs. Now it's time to actually generate the code with using the template. So this is a struct template. At the top we put the package with the name field. Here's a warning as a comment that this is a generated file and should not be edited. And then import format. Yeah, so this is for outputting the string function. And now we print out the enums. So from the enum field. And now there's another directive I haven't talked about yet. With the $sign, you can create your own variables inside the template. In this case, when iterating over enums, the name of that enum is not accessible when we also iterate over this values range. Then name is actually the name of the enum value. So the name of the enum we're in would be lost. So this is why we save the enum name to this variable. Now we can access this, and this is how we iterate over the enum values. This will write to do state created, for example, and the enum name is to do state, and then there's the value created. Iterate over that, close the iteration over all enums. In this case, we only have the one enum, but potentially you could have more. We generate a struct, which iterates over the fields with name and type. And then we build the string function, which uses format as print and yeah, the name of the struct, iterate over the fields again, print out the name and the value, and yeah, that's it for this template. How is it all put together? One thing to also talk about is formatting. So, okay, we generate our struct from this. We give in the to-do entity struct, the name of the structure generate to-do, and the package. Put it in, which is also to-do. Generate a template out of this. We have the buffer. So now we're going to format the result. So Go contains a formatter that is, so Go format is command, right? But the formatter is also accessible via code. And we quickly show you that the function we're going to call format source, format package and source, and give it the bytes. And this calls the Go formatter. And this way we don't have to care too much about the formatting the struct template when we write our template, because well, it comes out formatted at the end in proper Go format. And then we write out the file. This case, underscore gen is the name of the file. This is the folder to write the to-do folder for the to-do package. And underscore gen is to show that this is a generated file. Let's see it in action. These are all the helper functions. Now we have our generate to do. So it calls, like I said, parse struct, right? Creates template string, forms a result, and then writes. And again, so it will write it here to do, which will create to do go, to do underscore gen go, of course. Sorry. Well, let's run it. And here it is, freshly generated, pristine. Gotta love it. So, one more thing. There's the go generate command. You run it with go generate, and it goes through all the files in your project and looks for comments that start with here go colon generate, and then it executes everything that comes after that. So in this case, go run generate to do go, so our generator function. So in that main file, so if you put this in the main file that generates the to do struct, so now when running go generate, then generate to do go is automatically executed. And like this can be useful for everything you want to do during the generate run. So you can generate more entities, other repositories, whatever you want, or format your code with something else, or you can just run arbitrary code. So I can show this as well. Here it is, go generate, go run generate to do go, so this file. So go generate, let's delete this file, and so go generate, and there it is again. So yeah, what else can these generators be applied to? Well, like I said at the beginning, any repetitive task with only slight variations is a great example, or is a great candidate for code generation. And one example for that is generating simple CRUD operations for repositories that access the database, or you can also create then mocks of those repositories for testing. Can even write graphical user interfaces, like it could be just websites, automatically generate those websites and the routing and everything for that. Yeah, so, but really, like I said, anything repetitive. So let your creativity flow with what you want to generate, and let's see where it goes. I mean, if you generate something, write in the comments. I'd like to know what people generate. In conclusion, writing code generators in Golang is not that hard. Just try it out, let your creativity flow. And all the code can be found here, which is also linked in the description. That's all.